All right. So we are live, I believe. Welcome, welcome, welcome. It seems that saying things many times over is really the theme of this conference, which I like personally myself a lot. So welcome everyone to developer conference on my behalf as well. And let's get started. A couple of things, housekeeping notes. You might have seen these here before. So this is really a note to each and all of us. Here's a code of conduct for the conference. A couple of things that should always be obvious, but there's good reason for us to state these things from learning from experience. Let's try to be as inclusive as possible, respecting each other. We all come from different backgrounds, access to technology, different education, and so forth, different paths of lives as well. So let's try to understand each other, and let's assume the best intent of all of the questions and interactions here. Here's a quick note for the fundraising. The organizers are running to something that looks very interesting indeed, the National Museum of Computing for UK. Very interesting to see if any of the sponsors or any of the attendees want to support this worthy cause indeed. And speaking of sponsors, I understand a lot of the organizers come from Black Marble. They're putting a lot of their work and sweat and free time on a Saturday in. So thanks a lot for that. Thanks Microsoft for providing the swag, providing different learning paths, this Teams Live and so forth. And thanks a lot to the regular sponsors who are now turned into fundraiser sponsors from earlier years as well. And also a quick note to an upcoming session, NDC London, happening in a month or so. Go ahead and check them out if you're looking for more content as well. The official hashtag DDD 2020, very repetitive. I liked it a lot. And the official handle in Twitter is Developer Day. With that, the housekeeping is done. We can turn to the topic of this session, which is top Azure fails and how to really avoid them. Quick introduction from myself. My name is Karl Ots. I'm an Azure MVP and a Microsoft Regional Director. I come from Finland. Currently, I live and work in Switzerland. I'm working in a financial sector, working in a big in-house, very security-minded organization, working in a big in-house cloud transformation journey. But today I'm here talking not on behalf of my employer, Swiss Re, but as a fellow member of the community. And before we get started, so this style of the session, or the session format, is as follows. I have been working with Azure for 10 years now, and I've seen different organization sizes, different expertise with Azure, different approaches. And even if a team is a big team, they've done this before, this is their 10th or 100th Azure project, there are some of these things that I see just keep on repeating from the security point of view over and over again. And they can be called misconfigurations or anti-patterns, but in all honesty, from security point of view, these are not intentional. These are something that we should know better, and these can create a lot of damage on that side. And I do call them fails for that purpose. So the idea is that based on my war stories, or based on my experiences working with Azure with different customers, different projects, different organizations, this is a collection of these where I put together, which I've seen keep on happening all over again during this 10 years of Azure. And I really hope I will be able to change this. But the more I talk about this, the more relevant these seem to get. So bear with me if some of these are some that you think everyone should know. They really are not. So let's get started with the first topic. Fail number 1: unprotected public endpoints in the public cloud in Azure. We should not be talking about these topics, but yet we still are. We are time and time again talking about this. Here is just one example. I've collected information from 2 virtual machines running in Microsoft Azure for 24 hours. They are fresh machines, kind of straight from the Azure Marketplace. They are patched and updated. Everything is done, but by default they are there, available as unprotected, as I want to myself go and connect there to the RDP. And during this, just a little experiment that I ran for the 24 hours for those 2 machines, you actually see that we were getting failed login attempts of to those Windows virtual machines to over 3,000 different usernames. So this is not just 3,000 failed login attempts, which I'm querying here from the Windows event log ID, but I'm actually summarizing those by the targeted account that was used. So of course we see administrator tried to be logged in over 22,000 times, different variations, different spelling. There's a Scottish, or I don't know if this is a Swede administrator there, and different versions there. This could be a password spray attempt. This could be just another brute force attempt, but this is what happens when you keep your endpoints in anything open in the public cloud. The IP addresses are public, they are available, they get immediately scanned. There's a couple of minutes, somebody tries to log in using those management ports, tries to see what is available in your environment. So what should you do? Well, first of all, anytime you think of creating a public IP address resource in Azure, you should really be carefully considering, is it worth it? Why am I doing this? And specifically related to the IP address as well. Any public IP address you manage in general, but specifically in public cloud, is a risk, and you should really carefully review whether or not that is strictly necessary and which protections can you put in place there. If you're dealing with infrastructure as a service, as I just did in my example, there's plenty of Azure native options available. There's network security groups, which are good enough if you just want to block the access. They can be complemented with some traffic analytics, but that's pretty much it. You could add some user-defined routings, force everything to go to an existing infrastructure as a service based networking device, but that's pretty much it. The security center just-in-time access to limiting the amount of time you need to keep those network security groups open. There's even a nice HTML5 based Azure portal-based RDP and remote connection protocol as well, using Azure Bastion. And there are different options which you can use either from those marketplace gallery images, or for example, services like Azure Ban Manager or Azure Firewall there. Use them. If you're dealing with Azure Platform as a Service, and specifically when you're dealing with those services where you store your data, I'm talking Azure Storage, SQL, Key Vault, Databricks, all that jazz. You have plenty of options available natively there. The UI are similar, the terminology are similar, not always exactly the same, but the key components are there. You can open connections, limit connections, not just to the public, which is the default interaction. You can use service endpoints. You can even use private endpoints so that you can protect not just the incoming traffic to your data services, but also the traffic that goes out. You can actually prevent this data exfiltration, someone reading, not just storing the data, but actually reading that data and consuming that outside of your designated areas. And there's something called quote-unquote firewalls, which we don't really have even on the infrastructure as a service side, but on the platform as a service data side, that really just means which IP addresses are allowed or not allowed to access this data service we are using, or which virtual network service endpoints, private endpoints, are allowed to do that. use these. Here's an example of that firewall. I'm in my Azure storage account. I've selected specifically inside firewalls and virtual networks, I've selected allow access from selected networks. It's not turn firewall on, but that's what it effectively does. The terminology is slightly interesting there. And by default, I have two places where I can actually configure this firewall. I can add these virtual networks that are allowed to be accessed here, but I can even add also these IP addresses, which may or may not be within those IP address namespaces of these virtual networks. So these are actually two separate controls. I could say that there's a huge virtual network and I also or this specific subnet that I'm looking at, but I only want this particular IP address range to access this storage account. Or I could say that there's this trusted virtual network, trusted subnet that we are managing in our environment, but specifically, in addition to that, I will also want to maybe add my outgoing proxy addresses of my corporate network also to be accessible here. So these are separate from each other. You should use them in conjunction. And then we have this dynamic list of IP addresses that Microsoft manages, these trusted Microsoft services, which unfortunately don't include services like Azure DevOps, but do include services like ARM template deployment and so forth. This is a dynamic list by that link over here in the information box. You are actually able to see which services are covered in there. And if in some cases you actually do need to grant access to some users that you don't really know where they're coming from upfront, when you are generating those shared access signature tokens, those short time-lived tokens that can be used to access the data, not anonymously, but based on your business logic. For example, if you are selling some let's say video files that you're hosting on your blob storage, you might create as part of your purchasing process. You might create this SS token and share that token, that IP address that can be used for a short period of time and can be used to download. Or more specifically, we can even set some more POSIX-like permissions here as well. That what is allowed to be done using this shared access signature with no further authorization as well. But there's more. Even if I see organizations or teams using these SAS tokens and generating them in a very fast pace and having good management on that, they don't always know that you can actually create, when you create those SAS tokens, you can actually create this list of allowed IP addresses as well. So you can actually fine tune that. Even if this SAS token somehow gets leaked, you can actually even go more deeper and say this can be used only from this location, as well as enforcing HTTPS access here too. All right. Let's move on then and talk about broken authorization. This is one of my favorites personally, and we can go on a long rants on this particular one as well. I really mean broken. So typically when I go and scan for existing access in a large or any Azure environment, I see that a lot of the users in Azure are granted in the owner, and even more worryingly, they might be granted in the subscription scope. And this is usually happening because the owner is the default role for a new subscription. So if someone starts playing around with Azure, they don't really have their plans on, they don't think about strategy, they don't think about governance, they don't want to maybe wait for that internal team to think about these things, they just want to get started. But when the first developer gets in, they get this owner right, everything works. When a new person joins a team, they don't really know what's happening next. We don't know what's the proper answer. Maybe it's a contributor. Let's start at a contributor. But there are some things that don't work with contributors, such as inviting new people in, maybe setting registering some resource providers, maybe adding some logs, etc. So quite easily they think, okay, let's just give them all of the access that the previous one had. And that's not really a good plan. All hell breaks loose with that. Because an owner can manage user access as well as manage access to the resources and the content of those resources in the scope it is given. That means that the user the owner is effectively someone with unlimited credit card credit. They can create any sort of cost, they can create any sort of new resources. They have an invisibility cloak because they can effectively just kick everyone out or delete all resources that store logs, or they can remove the logs from being emitted. And effectively, they have this bulldozer that they can use to just delete everything that anyone has created. And again, they can by default invite anyone with an email address, not just anyone from your organization or from your trusted partners. So what should we do? Well, we started with this owner, which is the default role which you have, and you typically set and you have that in the subscription scope because there's nothing else. You could start having your resource groups, your resources, sub-resources when we are dealing with app service slots, for example, when we are dealing with virtual networks in Azure. So you should think about that scoping there, of course. But owner is actually a role that can be split into two different roles, which you should use. There is the contributor, which I mentioned, which is the super user. It's a very modest name. I like it as a Finn, I like it. It's a contributor, but actually it's a super admin. It can do anything except managing access, except inviting new people to the management pane of role-based access control. So despite its modest name, I encourage you to move as many of your owners to contributors as possible. You limit the damage of how far can it spread from there. And instead of owner, you should use something that's actually meant for that, called user access administrator. It's a built-in role. It's been there for ages, but unfortunately, it's not listed at the top 3 roles before all of the built-in roles are listed alphabetically, where you have owner, contributor, reader, and then everything. You need to scroll down all the way to you and starting with user access administrator. And that's a role that has everything that the owner have. So they have access to star access to any resource provider to do anything except what the contributor has. So effectively, they only have read access and they have access to do anything within the Microsoft.authorization resource provider, meaning inviting new people in, meaning kicking existing people out, meaning managing access, meaning setting logs, policies, etc. So instead of owners, if you have project managers, people who don't need to do anything else except just invite people and manage access, give them the user access administrator, and for others, give them the contributor. But that's not it. If you start doing that right now, you might start seeing that the contributor role actually has the power to grant user access within a lot of services, and especially these data services, native database as a service components such as Azure SQL. If you are a contributor, you can actually go in and change yourself or change anyone to be the SQL database level administrator. Then you can do anything with the data. Then you can get the data in. Then you can grant new people access to the data. The only benefit there is that at least that access is managed. It's tied to the Azure AD tenant, which means that you can only get your hands on the data, and anyone who is already onboarded to your Azure AD. Possibly that's anyone if that's allowed in your organization, but at least you're not just able to create manual resources, manual users there. All right, and then we have the storage account, BAM, here in the middle. As a storage account, as a contributor that has access, inherited or direct access to a storage account, you are able to create and manage those storage access keys, those real authentication keys that can do anything. They are legacy keys. You should not use them at all. You should punish everyone who uses them. But they are the keys that if you're a contributor, you see those keys, you're able to list them, you're able to regenerate them, which means that you will break any SAS token used with them. They are bad, bad, bad things, and you should not grant that access to anyone. Instead, there are role-based access control, built-in roles for data pane as well, which you should be using, granting reader for the management pane and specific purpose, even like storage blob data owner level roles for your devs, where they can do anything within the data except grant that access away. And lastly, we have the Azure Key Vault, our place for storing and managing our most precious secret certificates keys in Azure. By default, there is this ugly access policy, which they are, unfortunately, they are getting away with. This access policy is something that a contributor can go in and select who has access to these keys, what can be done, which permissions, no scopes. It applies to everything in that Key Vault resource. There's no folders, anything. That is something that there is now available, a control which you can do. When you create your Azure Key Vault, you can enable RBAC-based access control that disables all of those legacy access policies. Please do that. It's still in preview, but it's working very well. Please get your head around using that, and immediately when it gets out of GA, start dropping those access policies and go to the data pane RBAC for your Key Vault. All right, I wasn't kidding when I said this is a rant-worthy session, and specifically a rant-worthy topic, this number 2, broken authorization in your environment. Let's move on. Sorry, we did not move on. Yes. In addition to those roles, there is the scope that I mentioned. Don't start with the subscription level assignment. Minimize those. Actually prefer this resource group or even resource level assignments. When we are dealing, unfortunately, we don't have a deny assignment. You can't say by default that I will grant you contributor access to everywhere except these storage accounts. That's not how this works in currently in Azure Resource Manager. It means that you need to go ahead and maybe grant reader access to the subscription level and then contributor only to specific resource groups or specific resources that you are actually wanting to manage with contributor. Keep that in mind. It's not just the roles that you are granting, but specifically the scopes. If you find yourself starting to work on custom roles, ask yourself, why am I doing this? And most likely the answer there is that you are doing something wrong. You are breaking the system. You are not using the scoping as effectively as possible. All right, let's move on to number 3, which is really missing audit logging. And we had broken authorization. Audit for audit logging, I mean, it's not even broken. It's not just there at all. If you're familiar with for example, OWASP testing framework for web app security, you might have seen this item called insufficient audit logging, but this is not even that. This is really missing audit logging altogether from your environment. Most Azure services don't actually create any type of audit logs by default. The only thing we have available is simply this Azure Resource Manager level audit logs, which gives some activity logs available, and even those are available for us only for 90 days by default. There could be noise, they could be irrelevant, they are not always as detailed that we would want. So what to do? Oh yeah, this is even true for services that should not. This should not be true, such as Key Vault, where we actually want to manage access and get those audit logs, or even web application firewall. Who's heard of a firewall that does not store any logs? Ridiculous. Turn those logs on. And funnily enough, it's not called audit logging for most services at all, at least anymore. To turn on audit logging, you need to go under you need to configure something called Azure Monitor diagnostic setting. In ARM or command line, you just create a under Azure, you go and in addition to the resource you are creating, you are actually linking that resource into a new Azure Monitor resource provider resource that you are creating of the type diagnostic setting. And then you are just linking that this resource is emitting these diagnostic settings. In the portal, you just go into resource, navigate to resource, in this case Azure Key Vault, under monitoring, go to diagnostic setting, create a new diagnostic setting. And now this part is then different from each different services. You can select the logs, log types available. For Azure Key Vault, there's something called Audit event, which seems very interesting, that actually stores those audit logs. And then there are some performance metrics available in the all metrics log type. They are then created as separate tables in wherever you are storing your logs. And you can select from an Azure Storage account, an Azure Log Analytics workspace, or if you just want to consume those outside of this environment, such as if you are dealing with a CSP scenario in Azure, if you have a separate Azure AD tenant in your organization, be it from geopolicy or some other reason, or you just want to take those logs in and consume those somewhere else in a third party, then you can use Azure Event Hub to do that. That's your integration point to QRadar, to anywhere else. And there's more. Azure Defender, or service formerly known as Azure Threat Protection, or some other names as well earlier, is really a collection of more or less automatic parts of actually reading those logs. So now that you have your logs turned on, it will be nice if you would actually have a look at those logs from time to time as well. Azure Defender makes the machine do that. And here's a bunch of examples which we can see. There's anonymous access to storage, there's data exploration, there's data exfiltration. Something very usual happening. Normally these credentials are being used to just add some maybe once a day some data. Now they are pulling everything out. Somebody suddenly started changing permissions, somebody actually accessing this from an unusual location, somebody uploading a malicious executable, and so forth and so forth. These vary from service to service. This is even available in the Azure Resource Manager level. Amazing. You should always turn this on. This is effectively just turning on ATP, Azure Threat Protection, or just the paid Azure Security Center for that specific resource type. Officially, it should be called Azure Defender for storage, Azure Defender for SQL, etc. But there are still some naming. The naming is not as coherent yet, as this change was announced in this fall's Ignite. Here's one of these examples. When we turned this on in a project, we started getting this message, or we got this message the same week, saying that someone had signed into our storage account from an unusual location. And they were using Firefox to do that. That's weird, but my preference myself as well. But more specifically, they were logging in from Kuusankoski, Finland. Well, if you think of Finland, that's in the middle of nowhere, and then you go a little bit more north from that. And then Kuusankoski, Finland is literally in the middle of nowhere. So no one was supposed to work there. It just so happened that one of our colleagues actually just started their vacation a little bit earlier. They wanted to do some remote work from their cottage. They just didn't tell us, but Azure Defender told us. Amazing. For those activity logs, such as this very powerful contributor coming in and listing those storage account keys, you can actually create custom alerts. I recommend creating those alerts for Kubernetes, Azure Kubernetes Service Cluster credentials or storage credentials as well. You can consume these in any webhook, any bunch of different built-in integrations. Personally, I don't have email alerts or I don't have email coming into my phone, but I do actually have Azure Portal app installed, so I can get push notifications myself as well. Here's an example, getting a push notification from someone listing those storage account keys, and then I can perform any of those actions that are necessary. The machines can do so much more for us as well. This is App Insight giving us information that now this particular site is actually getting some service performance degradation. Maybe this is some sort of a denial of service attack. We don't know yet, but at least based on this analysis, 10 seconds of response time, 1,000% slower than normal. Phew, it's not just our app that's slow, but it's actually something interesting happening right now. Let's go ahead and investigate. All right, moving on to our fourth of my top Azure security fails. Storage accounts specifically. I called these out earlier already in the access control and in the logs, but now let's talk about those storage accounts and why they are something that I don't want to see you using anywhere in any of your projects. If you need to use those, then definitely you should set up some automation. You should store your keys in Azure Key Vault. You should build automation to rotate those. You should never check from the storage account service yourself those keys, but you should always get the freshest keys available from the Azure Key Vault. Even better, if you are building a new application, use those data pane role-based access control roles. We have a ton of roles available. We have different roles for different type of storage. We have storage blob data contributor. We have storage blob data owner, reader, etc. Use those roles, and then you will always have the log of who was actually accessing this data, not just that someone was using this key, which is shared across everyone and ever so often available in GitHub. We will always have proper authentication. You can always add anything that you can add on your Azure Active Directory level in your organization. You can add conditional access, all that jazz. And for the forensics purposes, you get to know who was actually performing those accesses. You get a list of everyone indisputably who has ever accessed these storage accounts. After you set that up, you can start restricting people's access to Microsoft.storage resource provider, and underneath there, the storage account list keys action. This is just a REST call. This is just me going as a contributor to the portal, listing those keys, or this is me trying to perform that action from some other way. I can add some Azure custom policies. I can work around that using meticulous scoping in my roles. Just restrict access. At the very least, just see how often your team, your colleagues, yourself are actually using this ungodly functionality by just having that alert. Just set an activity log alert available for this, post that to your teams, and then start seeing how often does this actually get fired. You will be surprised. Yes. Untrusted authentication providers. The thing about Azure RBAC, role-based access control in Azure, is really twofold. We had the scoping, we had the access part, the authorization part, which is really about once we have authenticated our user, which sort of access are we granting them in which sort of scope. We had the roles available for that. That's all fine and dandy. But how about that actual authentication, which the RBAC doesn't perform themselves? They actually outsource that to a trusted authentication provider, to an IDP. Let's have a look. RBAC allows for any type of authentication provider almost being used. There's the Microsoft account, the personal user, the former live ID. There's Gmail. Doesn't matter if it's private or not. There's Azure Active Directory, anyone's Azure Active Directory. I can create myself for free. It can be someone from a competitor. It can be someone from our partner. And it can really be something that it's someone's self-hosted authentication provider, which we don't know when we are actually performing that RBAC assignment. When we are granting you access in the portal, wherever I'm doing that, I'm typing in the email address, I'm giving you the role, I'm giving you the scope, and I'm hitting send. A number of things happens. that email is actually being checked up whether or not this is actually it's available as a user in our tenant already in an Azure AD. If it's not, they get sent an email invitation. If it's an Azure Active Directory user, then it's a little bit easier. If they are not, they are actually able to set that authentication up themselves. At worst, it can even be something like just get a one-time use token, just get any access to this email address that's on the receiver side and re-authenticate using a code sent to that email address every 24 hours. That's not identity or access control. That's complete chaos. Some random person with an email address is not trusted authentication provider. So what should you do? You should always make sure that you are in control of the Azure AD authentication options of your Azure tenant, of your Azure environment. You should only use those trusted Azure ADs that you, if it's not yours, then your trusted partners, they are federated or they are managed in a formal manner according to your access control policies and processes. At least you should know who are those available, not just that anyone can create that new trusted link with default IDs, any-to-any connection. Effectively, any Azure AD by default trusts any Azure AD. You should maybe have a look at that. There's a service behind some paid licensing called Azure Active Directory Privileged Identity Management that actually goes in and checks the subscription access and checks the access against best practices. It gives you information, kind of complementing information to the Azure Security Center about which type of authentication providers are used, which type of identities are being used for access control in your Azure environment. It even sends you alerts if someone who is an external provider, external identity is, for example, suddenly now starting assigned or activating to a higher privileged role, such as a contributor or an owner. There's possible to limit this Azure AD guest invitation. If you have a process of onboarding guests to Azure AD, you can, and once you've set it up and share that with your users, then you can actually start screwing the control to a little bit more tighter setting, and you can start limiting who are you able to invite as a member or even as an AD guest. By default, a guest can invite more guests. Let's have a look at that. Here are some of those AD tenant level settings. If you have access to your subscription of your own and a tenant of your own, you are able to see this, but this is not always visible to everyone who is working in, is hopefully not visible to you in your day-to-day work in your organization. So there are some of these things that we can do. Can members actually invite new users? Can guests invite new users? By default, as you see, these are turned on. There's even something specific, an Azure AD level role called Azure AD Guest Inviter. We can turn off the invitation capabilities from both members and guests, but grant maybe to all of our developers, or maybe, let's say, everyone who has an owner could, for example, get this Azure AD Guest Inviter role as well, or a user access admin. There's the email one-time password, which I don't recommend you to use in this case. And there's also the opportunity to start maintaining a list of allowed or denied domains. If you are very strict in managing your access, I recommend having a list of each of your partners actually being onboarded or invited as guests. As part of that process, when you review if this is a guest that you want to allow, you should then add this in this allowed invitations list in your AD. This affects not just your Azure environment, but of course any of your teams, SharePoint Online, Exchange Online, all of those environments as well. And once you can actually trust that identity, then you can verify. Trust but verify. There's a beautiful setting called Conditional Access, a feature in Azure Active Directory that lets you configure additional controls, such as network controls, such as additional MFA, such as checking even authorization settings per application level. We can actually configure our services in Azure, such as the Azure Web App, to be accessible only after a successful Azure Active Directory login, and we can configure our conditional access so that only members in a certain group, for example, can access that, successfully perform that login. That's all of our application level authorization setting done in the centrally managed platform. And the beauty of that is really that for that application, our admins can then go in and have a look at these failed, interrupted, or even successful sign-ins and have a look if everything is set up correctly. If there's some conditional access, which conditional access was fired, why was this authentication now failed? They even take into account this risk profile of what actually is happening with that user, which device even they are using, are they coming from a known network IP address that is maybe in a malicious ISP, or it's just part of a botnet. All of that data is aggregated and taken into account in addition to your conditional access that you set. And all of those logins are then available for your application even that your devs are building on their own, just with the contributor access and the access to register new applications, which is another Azure AD role. All of that put together, you can get all of this nice and beautiful central logging available from all of your application access when you trust your authentication provider. All right. We are about to wrap up and start our Q&A. A quick call to action to everyone. A lot of these things can be actually found using something called Secure DevOps Kit for Azure, AZSK. I really recommend you to look at this. This is a PowerShell tool that you can run. Effectively, it's just a PowerShell module that you install. You need to be able to connect to your Azure environment, and you need to be able to have at least reader access to your environment that you're scanning, and that's it. That's very non-intrusive. You can run it on your own. You don't need to tell anyone. You can just go ahead and fix these things. azsk.azurewebsites.net. This is built by Microsoft IT. That's a tool that they use to secure their own environments. Here's a picture of a PowerShell. We know how it looks like. All right. And in addition to that, I really recommend you to look at this new tool, this new set of services called Azure Security Benchmark. It's available behind that link, or just search using your favorite search engine. You will see this. It's a collection of best practices, security baseline, even complementing Azure Policy Initiative. That's if you just want to take use of this from the moment you get started using your Azure, you want to know that you are really strict with your security. You have all of the visibility available. Check it out. A ton of good material mapped into compliance frameworks, mapped into NIST, mapped into CIS, all of those others. And that's it. That's the end of our session, which means that it's now time for some questions. All right. If you have any questions, please feel free to use the Q&A button here. It's going to take, I think, maybe 20 seconds or even more for me to see those. So I'm just going to stay here for a while, answering any of those questions here. If you want to reach out to me later, I'm available in Twitter. Just check out at Karl Ots, and I do a lot of stalking, I do a lot of lurking, and mostly just promoting Azure content in there as well. My DMs are open. Feel free to reach out to me in there as well. With that, thank you very much. If there are still any questions coming in, I'll be happy to stay here and answer those as we go.
No, Carl. So the session evaluations, I believe, are through another survey which is linked on when attendees join. So no, there's no extra pamphlets that we have to rush out and give to anyone who's joined for the session.
All right.
And I believe if we have no questions that we can close this up. If anyone does have questions, then I believe they should have your links, Carl, or they can send them through to ddd@blackmarble.com, and we'll forward them on as needed. But otherwise, thank you for the session. Thank you for everyone who's joined and watched through the session, and we'll look to close this off now. Give chance for people to get a coffee before the last session of the day.
Excellent. Sounds good.
Okay.
Have a great day, everyone.
Okay. Thank you very much.